In this video, we are going to talk about parallel and perpendicular lines and their slopes. Parallel lines are lines that never intersect. They look something like this, where the slope of two lines are both positive, then the slope of two lines are both negative, and they could also be two vertical lines, or they could be two horizontal lines. Now, when you compare the slopes of these parallel lines, they should have the exact same slope. So m sub 1 equals m sub 2, where m sub 1 represents the slope of the first line and m sub 2 is the slope of the second line. Perpendicular lines are lines that intersect at a right angle. So it looks something like this, where one slope is positive and the other one is negative, and they intersect at a 90-degree angle. There's also a special case where you could have a vertical line and a horizontal line, and they also are perpendicular to each other. In terms of slope, two perpendicular lines will have slopes with product equals -1. So when you multiply the two slopes together, you get -1. That's one way to think about it. You can also think of it as one slope is equal to the negative of the reciprocal of the other slope. Now, with the second scenario here, where we have the two special lines, vertical line and a horizontal line, we know that the slope of any vertical line is always undefined, and the slope of any horizontal line is always 0. In this case, we can't multiply the two slopes together to get -1, so that's why we call it the special case. Let's look at some examples. Write an equation of the line passing through the point -4, 1, and parallel to the line defined by x plus 4y is equal to 3. Write the answer in slope-intercept form and in standard form with no fractional coefficient. So we know the equation of one line. Let's focus on that line first. X plus 4y is equal to 3. Right now, this equation is in standard form. To be able to tell what the slope is, we need to convert it to the slope-intercept form by getting y by itself. So first, we're going to subtract x from both sides. That will result in 4y is equal to 3 minus x. We'll then divide both sides by 4. So that will give us y is equal to 3/4 minus 1/4 times x. Remember, the slope is the coefficient of x. So the slope here would be -1/4. Now let's call this the second line. We know that the line that we're looking for is parallel to this second line, and we learned that two lines that are parallel to each other will have the same slope. So the slope of the first line must also be -1/4. In addition, we know that the first line passes through the point -4, 1. So we can use the slope-intercept form with the slope being -1/4. Let's call this m sub 1. And the point passes through to find the equation of the line. Now this will be x, and this will be the y coordinate. So let's plug them in. Y is 1, m sub 1 is -1/4, x is -4 plus b. So we just need to solve for b, and then plug m and b in the slope-intercept form to find the equation. So -1/4 times -4, this is like -4/1. That will give you +1 plus b. So subtract 1 from both sides to get b by itself. You should get b is equal to 0. So the equation of the line should be y equals -1/4 times x plus b, which is plus 0, but we don't have to write that. So let's just leave the answer this way. So there's a slope in the set form. Now, how do we convert it to the standard form with no fractional coefficient? So the standard form is ax plus by is equal to c, where x and y must be on the same side of the equation. So what we want to do is to add 1/4 x to both sides to move 1/4 x to the left side. So the right side would be 0. We don't want any fractional coefficient. Right now we have 1/4 is a coefficient for x. To clear out the denominator, we can just multiply each term by 4. So that will give us 4y plus, now this 4 and that 4 will cancel. So you have x, and then 4 times 0 is 0. So here you are, the standard form of the same equation. Let's look at example 3. Write an equation of the line passing through the point -4, 1 and perpendicular to the line defined by x plus 4y is equal to 3. So as you can see, this problem looks exactly like the example we just did, except instead of the word parallel, we have the word perpendicular. But the good news is we don't have to redo the work for slope in the set form. Again, we convert this to slope in the set form, and we got 3/4 minus 1/4 x, just like what we got up here. And then we determine that the slope, let's call it m sub 2, is equal to -1/4. Now the first line is perpendicular to this line, and so the slope of the first line must be the negative of the reciprocal. So negative, which means it's the opposite. So this one is negative, so the second one must be a positive slope. Reciprocal means you just flip the fraction over. So 1/4 becomes 4/1. That is just 4. So the slope of the second line must be +4. Now, we write the slope in the set form, y equals mx plus b. And we know that the slope now is 4, and the point that it passes through is -1 or -4, 1. So let's plug them in to calculate b. So y is 1, m sub 1 is 4, x is -4 plus b. This will be 1 is equal to -16 plus b. We need to add 16 to both sides to get b by itself. So b is equal to 17. So the equation must be 4 is m, x plus b, which is +17. Now we convert to the standard form. All we have to do is just move the x term over. So that will be 4 minus y minus 4x is equal to 17. And there you have the slope in the set form and the standard form.